What's up, y'all? This is a video about statistical validity. Well, one aspect of statistical validity, p-values. Now, usually when I ask students what they think that means, their first answer is whether the p-value is low. Is it less than 0.05? If it is, we reject the null hypothesis. If it isn't, we don't. But that's not what I mean today when I talk about statistical validity. It's not about whether your p-value is low enough. I'm talking about whether the p-value itself is valid. Think about it like this. You ran a study. You calculated a p-value. But should you trust that p-value? Should you use that p-value as the basis for the decision to reject the null hypothesis? Here's 3 reasons you might not. First, maybe you ran the wrong test. Think about someone who runs an experiment with 2 groups. They should do a t-test, right? But what if instead of a t-test, they do a correlational analysis? That p-value shouldn't be used as the basis to reject the null hypothesis, that there are no differences between those 2 groups. Because they ran the wrong test, that p-value is invalid in the sense that it shouldn't be used to reject the null. A second reason a p-value might not be valid is if it's based on a small number of observations. Do you have 10 people in your study? Or 100? Or 1,000? The more people in your study, the less likely that p-value will change if you keep adding more people to your study. This is because when you have a small sample, each additional observation adds a lot of information, proportionally. Going from 10 to 11, that 11th observation might change things a lot. The p-value could go from very low to very high. But going from 1,000 to 1,001, well, that p-value isn't going to change much at all. So you shouldn't trust a p-value that is based on a small number of observations, because that p-value is likely to change if you were to keep making observations. Now let's talk about a third reason you shouldn't trust a p-value. We just covered how more observations is better, right? So you might be tempted to run a small number of people in your experiment, check your p-value, then run some more, check again, run more, check again, until either you get a low p-value or things seem to stabilize. But you can't do that. Every time you calculate that p-value, you are increasing your type 1 error rate. This is the chance that you reject the null, even though the null is true. Or said another way, this is the chance that you conclude your hypotheses were supported, even though, in reality, they are false. It's easy to say you won't do this, but how can you prove it? When someone reads your paper, they don't know how many times you stopped data collection to calculate a p-value. For this, you need a way to publicly declare you won't do this before you run the study. You need a way to tell the world that you will stop data collection after 200 participants or on a particular date, like maybe the last day of the semester at your school. The way you do that is with something called a pre-registration. This is a document that you create and upload to the internet. It has a date stamp on it, and you can't change it. So another way a p-value is valid is if there is a pre-registration with a declared stopping rule. We're stopping after 150 participants, or we're stopping on the last day of class. So to sum up, this was a video about the type of statistical validity that refers to whether we should trust p-values, not whether p-values are low or high. We covered 3 reasons we shouldn't trust a p-value. If we did the wrong analytic test, if we have too few people or observations in the study, and if we don't have a publicly declared stopping rule.